So let's start off with the very basics. Okay, if I am going to measure the motion of an object, say we've got an object sitting here, okay, whatever it may be, okay, we need to know how to locate that object, right? So if you've got, say, if we're in the classroom and over here we have the door to the classroom, we need to be able to identify how far away this object is from the door, right? So if we say that it's 10 meters, that gives us some concept of the location of the object. So basically what we've given you is what we define as position. Okay, it's not a difficult concept, right? You've heard the word before, but this refers to the location of an object in reference to an origin. So in this example, our origin was the door. Okay? And in units, we measure it in meters. Okay, because for physics, we're using the standard unit of measure, so length measurements should be in meters. Okay, now before we go further, we need to identify a couple things too. First is, in physics, you have two types of numbers. Okay, so let's write that down. Types of numbers. You have vectors and scalars. Vectors, these are numbers with magnitude and direction. And scalars are numbers with magnitude only. All right, so what do we mean by the terms magnitude? Okay, so magnitude is essentially the length that's measured, the strength of a force, okay, and so on. It's just simply the number. And then direction you'll typically see in two ways. Either one, it's a plus or minus sign, or given by an angle. So you could see a direction in one of two ways. All right, so in the example of the door, we have the magnitude, 10 meters. Okay, and so if we're going to make this a vector, we need to know specifically where those 10 meters are. Are they behind the door? Or are they in front of the door? Okay, and that specifies a direction. So by saying the object is 10 meters behind the door, we've now given a vector. We've given it magnitude and direction. All right, from that, we're going to talk about what happens when you change your position. So if we're doing an experiment, let's say we're outside and we see a car going by. Okay, at one point we see it start at some position. So let's call this position 0. 0 represents a good spot to pick an origin. Okay, now some time later, the car now appears at a further position. This new position is, well, we'll call it position 1, but I don't want to confuse that. That's not 1 meter, that's just position 1. Okay, so if we started at position 0, now we're at position 1, and this occurred in some amount of time. Okay, so the first thing we want to look at is how far did you go? Okay, so if we started at position 0 and we ended at position 1, how far away is the car from where it started? Okay, well, there's two answers to that. If I say, we'll change this up. Let's say we start at position 0 and we travel, again, we'll go 10 meters. Okay, so then to answer this question, well, there's two ways, right? You could say I am 10 meters from where I started, right? So 10 meters from where the car started. But that would be a scalar number, because you'll notice there's no direction there. But if I were to say 10 meters, say to the right or east, or some other term to specify a direction, then we've given a vector. So from where the car started, now we have a vector. Okay, and we can take this a step further and actually identify a couple things here. We can say that the scalar is actually given to us as a distance, and the vector is given to us in what we call a displacement. Okay, so let's take a sidestep here and understand the difference between saying distance and displacement. So if you have a distance, if we're going to look at distance first, so let me write this out. So if we're going to look at distance, think of it this way. If we have a general kind of two-dimensional or one-dimensional city, right? You have, we'll say, your house, you have the school, and out here you have, we'll say, Kroger. All right, and let's give these some distances. We'll say the school is 4 miles from the house, and Kroger is 6 miles. Okay, so if we're going to look at distance, right, let's say we go from your house to the school to Kroger. So you woke up in the morning, you went to the school, and then from the school you went to Kroger, and then from Kroger you went back home. So what was the distance you traveled? Okay, well, if we start at home, right, if we call home our origin, so our 0 point, we started off going to school. Well, that was a distance of 4 miles. Now, we already said distance was a scalar, so it doesn't matter if we went to the left or to the right. We just simply went 4 miles. Now, from there, we went to Kroger. Well, if you look at how far away the school is from Kroger, that is a full 10 miles away. Then from Kroger, we went back home, which is another 6 miles. So in total, we went 20 miles. So that's the distance we covered for that day. Now, displacement is a vector. So how would things be different? Okay, well, again, if we started at home and we went to the school, we went 4 miles in the negative direction, to the left. Okay, and I'm picking negative to be left as an arbitrary thing, but let's just say, because we're used to that on a number line. So the school is 4 miles to the left, so we'll call that negative. From there, we went 10 miles to the right. So that's a positive 10 miles. Now, once we got to Kroger, and we went back home, so that's another 6 miles to the left. So it is also negative. Now, when we work this out, we get a total displacement of 0 miles. Now, that's true because when you think about it, displacement is asking for only two things. Where did you start? So what was the start? What was the end? And then it asks, what is the difference? Then it asks, what is the difference between those two? Okay, and that represents your displacement. Okay, so in our case, the house was position 0, and we started at the house and we ended at the house. And so simply put, we would say 0 minus 0 gives us a displacement of 0. And you could have picked this anywhere, right? If you started at the school and then you go through the whole path, you go from the school to Kroger to home, back to the school, well, the school is located at -4. So if you did the same thing, if you said, I started at -4 miles, and I ended at the same -4 miles, working this out would give us a displacement of still 0. So the difference between distance and displacement cares about the direction. So when you're looking for how far you went based on displacement, you have to include the directions from the origin. And in the end, all that really matters is where did you start, where did you end. Now, if you're trying to find distance, well, that one you have to actually work through without directional components. Okay, because we still covered a total distance of 20 miles in our journey, but we ended where we started. Therefore, our displacement was 0. So let's go back to the car example. So we mentioned that the car started at position 0, and then we added later that it ended at 10 meters, position 1, which we said was 10 meters away. Now we brought up that there was some amount of time. Okay, and so how does time play into this? Well, if we say that we completed this in, we'll make a number up, say 5 seconds, what we then get is, well, if we look at the fact we went 10 meters in 5 seconds, we get what's called an average velocity or an average speed. Okay, which in this case would be 2 meters per second. So what does it mean when we say average speed or velocity? Well, let's start with speed. So average speed, okay, tells us, well, rather defined, it's the rate of change of an object's position over time. All right, so rate of change of position. Now, speed is a scalar, whereas if we look at the average velocity, velocity means the same thing. However, velocity is a vector. It's still a rate of change of position, but now we want to know how much our displacement occurred to create an average velocity. So let's talk about what that means. Okay, let's say we'll do our car example. So let's say we went from, I don't know, we started in Augusta, so that's our origin. Okay, and in Augusta, let's say we travel at some speed, but we don't know what it is, so we'll say v. Then we get to Atlanta. Now Atlanta, if we over approximate it, we'll just make the numbers easy. We'll say it's 200 miles away. Okay, and let's say that we got there in, I don't know, we'll say we got there in 5 hours. Okay, we can look at what the average speed is by simply looking at that distance over time. So it's 200 miles in 5 hours, which means we were going in, on average, 40 miles an hour. Okay, but what if we were to change directions? So what if we did the same trip, but we add an extra stop? So let's say we turn back and we end up somewhere between Atlanta and Augusta. I don't know, say we pull off somewhere at Milledgeville. So now we're looking at 110 miles from Augusta, 90 miles from Atlanta. And again, I have no idea where these places are on a map, so these locations might be completely off, but that's okay. The idea would be, what if we turned back and we took another hour to get back to Milledgeville? So we did an hour to go back to Milledgeville. Well, in this case, what was our average speed versus our average velocity? Well, the average speed would say, how much distance did we cover? We went from Augusta to Atlanta, which was 200 miles. Then we went back 90 miles. But since we're only looking at distance, we would add that number because the direction doesn't matter. Now, how much time went by? We did this in 6 hours. Okay, so we did a total of 290 miles in 6 hours, which comes out to an average of about 48.3 miles per hour. But what about the average velocity? So if we want to find average velocity, now we want to look at the displacement. So how much displacement actually occurred? Well, we started in Augusta and we ended in Milledgeville. So what's the starting and end point? Right? We ended at 110 miles from home, with home being the 0 mark. And how much time did it take to do this? Well, it still took 6 hours. So now we find that our average velocity was only about 18 miles per hour. Notice the difference here, because average speed cared about everything that we did, whereas average velocity only cared about our overall displacement.